So this is an explanation of number 25, which is way too difficult to do via classroom writing it out. So I drew the 5 different functions, and so the function is drawn in black, and then I drew in the derivative, the graph of the derivative in red. So number 1, I think it is, or part A, whatever. So here's your sine curve. And remember, the derivative is the slope of the tangent line at a certain point on the graph. So if you look at from 0 to pi over 2, so remember I drew the functions in the color black. From 0 to pi over 2, the slope of the tangent is positive. So in red, from 0 to pi over 2, positive. But the slope starts off whatever it is, let's just say 6. And as you're getting closer and closer and closer and closer to pi over 2, the slope approaches 0. So at pi over 2 on the graph right here, the tangent line is horizontal, which means it has a slope of 0. And at 3 pi over 2, so remember I drew the sine curve in black. If you look at the sine curve here in black, at 3 pi over 2, the slope of the tangent line is 0. From pi over 2 to pi, so from pi over 2 to pi, again, look at the black curve. The tangent line is horizontal, and then it's getting more and more and more and more and more and more and more in the negative direction. Hence, from pi over 2 to pi, the derivative graph is negative. So you can see that the original sine curve and its derivative, the red curve, are not the same. Y equals x. Okay, again, I drew y equals x in black. Y equals x is a diagonal line through the origin, and the slope at every single point along this line is 1. And remember, the slope of the tangent line is the slope of the tangent line is where the graph touches the curve. Well, in this case, our curve is a line. So the slopes are 1, therefore the derivative is at y equals 1. Not the same. The line, the diagonal line, and the horizontal line are not the same. Okay, square root of x. So I drew the square root of x here. Again, I drew it in black. The derivative function looks like such, and here's why. So if you start with your curve, square root of x, and I start with my tangent line, well, the tangent at 0 is undefined. The slope is undefined, it's vertical. And so I'm a large negative slope, or start over. I'm a large positive, but as I approach infinity, the slope of the tangent approaches 0. So again, I'm at y equals root x, and if I start at the origin, here, I just found my ruler, so much better. Okay, and I'm turning as I'm getting the tangent, as I move up the curve of root x, the tangent line eventually approaches 0. Not the same. I'll come back to e to the x because that is the correct answer. Y equals x squared. Okay, so y equals x squared. The slope of a tangent, if I'm the point, let's just say on this point right here, let's just say negative 2, 4. The tangent line, it has a slope, a negative slope. And as I move down the parabola, the tangent narrows out to become, it's negative, and then the slope of the tangent lines on this parabola, as you go along the parabola, the tangent lines are approaching 0. Then, so hence why it's in the third quadrant. It's negative slope. So from like negative infinity to 0, the slopes are negative. From negative infinity to 0, the slope is negative. Then, when you are at the origin, which is a horizontal line, hence the vertex, the tangent line is horizontal, hence it goes through the origin, 0, 0. And so then, as my tangent lines, I'm going up and up and up and up and up that parabola, the slope of the tangent line is going up, 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 up. hence it is a diagonal line. So the last one is e to the x. E to the x. So e to the x, when you approach negative infinity, the right-hand limit, it approaches 0. So if I'm approaching 0, therefore the slope is also approaching 0. And on the curve of e to the x, okay, so my tangents, as I'm going up, 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 so these are, the ruler represents my tangent lines. I'm going up, 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 the slopes of all of those tangent lines increases. So let's say my point is here, tangent line, positive slope. Let's say the point I choose is here. Tangent line, slope is an even greater positive number. Here, tangent is an even greater positive number, such that it's approaching infinity. And there you go. The thing that's hardest for me when I was drawing these was recognizing, well, this isn't a function, but they're two separate representations. One represents the function itself, and one represents the derivative of that function. And remember, the derivative is the slope of the tangent line.